Hi, my name is Jacob Hill. My teammates are Georgie Zakharov, Austin Monson, and Dylan Navy, and we're the developers of Cypher, a programming competition hosting and management system.
Our product, Cypher, will support 4 different types of users. We will have competitors, judges, audience members, and systems administrators. Essentially, we will have a web interface for competitors to submit their code via either file uploads or raw text. And they'll be able to select from a drop-down menu what language they're writing the code in for us to then take the codes as a submission, compile it, and execute it. This is, of course, sandboxed within Docker, and it will also allow for judges to submit grading modules for the problems that they administer. What we have on our back end is essentially a manager that creates a thread pool of n number of threads. The number of threads is determined by the machine's core count, and this is determined at runtime, so it'll vary by machine. And it creates a central queue of submissions for processing. When the queue isn't empty, the queue is constantly being worked on by multiple threads. And the threads will each call Jake's submission processing system. For the sake of simplicity, we've defined a file system structure for Cypher. The user who's running the program, in this case Trump D, has everything within their home directory, home Trump D Cypher. And Team Luminous, for instance, right? You can find Team Luminous's submissions within the submissions folder under the Luminous folder. Now, their program files are going to be labeled by team name - problem number .extension, depending on what language they wrote it in, what file it compiles to. The special case being Java, where the name of the class must match the name of the file. So we needed to create an additional directory for that.
During our development of Cypher, we made the decision to store our files in databases instead of the local file system. To do this, we use Java and the JDBC, the Java Database Controller, which is built in and has compatibility with MySQL. Our database consists of 3 main tables and 2 child tables. The team table stores a team ID and a name. The solution table stores an ID, a language, a score, a name, and then has reference to a team ID in the solution storage table, and a long binary object, which is the solution source code. The problem table stores an ID and a name, and the storage table contains a problem description and the problem test code. Then I built an API to allow access to this database and ease of use between the front end of our Cypher program. It eliminates the abstractness of using the JDBC in the front end and allows for better error checking and simplicity of use.
So we decided to use Docker to provide a sandbox environment for compiling and executing source code we receive from our competitors. Docker is a commercial containerization software. It uses essentially containers which take an application and the libraries or binaries necessary to run that application, encapsulates that, and then it can be easily deployed to any type of target OS independent of the actual OS itself because of a Docker middleware running between the OS and the containers. So kind of the process flow of how Docker works in relation to Cypher, it starts with receiving a submission object from the backend manager. And the backend manager gets that submission object from the front end. And the submission object is nothing more than a series of parameters that are bundled within an object, like the team ID of the team that submitted the source code, the language the source code is written in, and of course the source code itself. The source code is abstracted from the submission object. Any necessary files or directories pertaining to the object are created. The source code, which is a string, is then written to a file with the appropriate extension, .java, .cpp, what have you. A Docker file is written. The Docker file is a template for building Docker images, which in turn are templates for building containers. So we start with a Docker file we write, we then create the Docker image off the Docker file, and then finally we run a Docker container from the Docker image. The Docker container terminates once it finishes execution, and then the output from the container is captured and returned to the backend manager.
In order for us to not start from scratch, we decided to use some of the widely used frameworks, 2 of which are Maven and Spring. What a Maven framework does is it preserves the run configurations of your project after you've deployed it, and it does so using a pom.xml file in which you will list things as dependencies, class paths, etc. Spring, on the other hand, is a framework that allows for creating apps, web apps, easier. Cypher uses Spring to manage UI applications that the user interacts with. With Spring, the front end is aware of the UI activity that the user does and is able to act upon it, such as request data or get data from something that the user posts. To establish a successful connection between the front end and the back end, we decided to use HTTP, which is the Hypertext Transfer Protocol. The HTTP has a lot of benefits, one of which is that if you're using different computers, if your front end is running on one and the back end on another, they can still talk to each other. However, if they're on the same machine, they can just use localhost. Now that we've talked about how we're communicating, we're going to talk about what we're actually passing, what kind of messages. And that's the backend and the front ends use a set of common classes, which we call common classes, to pass this kind of data. And Maven is, in this instance, helps to maintain the consistent file structure so that both of our applications are in the class path of the common classes.